Hi everyone, my name is Douglas from LD Talent. Today I'll be taking you through this HackerRank challenge. So let's look at the problem statement. The statement says Victoria is splurging on expensive accessories at her favorite stores. Each store stocks 8 types of accessories where the accessory costs $I for a range of 1 to A. Assume that an item's type identifier is the same as its cost and the store has an unlimited supply of each accessory. So probably what they mean by this is that a product of type 1 costs $1, a product of type 2 costs $2 up to A. A might be 6, A might be 7, A might be 10, but if A is 10, then the 10th item costs $10 and the 5th item costs $5. So this is what they mean by this statement. And Victoria wants to purchase a total of L accessories according to the following rule. Any element subset of the purchased items must contain at least D different types of accessories. What do they mean by this? For example, if L equals to 6 and N equals to 3, then D is also equal to 2, then she must choose 6 accessories such that any subset of 3 of the 6 accessories will contain at least 2 distinct types. So what they are meaning here is that out of the 6 elements that she has purchased, if you select 3 elements and you put them in a group, you should be able to form other groups that have 2 distinct items. For example, I'll give you an example. We have elements from 1, 2, 3, 4, 5, and 6. Let's say this is our L. This is what she purchased. Then, if we select 3 elements, 1 from this group, 2, 3. Now the rule says that out of these 3 elements, we should be able to at least get 2 elements that are distinct, which is what we have here. Or we can also have 1, or we can also have 2 and 3. So this forms our D, and this is our N. This is our N. Let's proceed. Given that L, A, N, and D values for T shopping trips, find and print the maximum amount of money that Victoria can spend during each trip. So they want the maximum amount of money that Victoria can spend. That means we start buying from the most expensive product. If it's not possible for Victoria to make a purchase during a certain trip, print sad. You must print your answer for each trip on a new line. Now let's look at some of the input formats. The first line contains an integer T. Let's look at these sample inputs. Now, the first line contains an integer T, which denotes the number of shopping trips. For this case, we have T equals to 2 and we have these 2 shopping trips. Now, each of the 2 subsequent lines describe a single shopping trip as 4 space separated integers corresponding to L, A, N, and D respectively. So these are respective. Now this is our L, this is our A, and this is our N, then this is our D. And they are saying we have 2 shopping trips. So this is the first shopping trip, this is the second shopping trip. Now let's look at this out. For each shopping trip, print a single line containing either the maximum amount of money Victoria can spend. If there is no collection of items satisfying her shopping rule for the trips L, A, N, and D values, print sad. Now, let's take a look at an example of some sample outputs. Now, initially for the first shopping trip, we have 24. Now, why do we have 24? Let's look at this explanation. Shopping trip 1. Which is this. Now, we know that Victoria wants to buy 6 accessories, which is our L. The store stocks the following. A equals to 5. That means we have items, if A is 5, so we have items 1, 2, 3, 4, and 5. So this represents our A. That means if Victoria is to create a shopping list, she can only select from these 5 items. But we can start with the 5th item. We start with the most expensive items. We can select like 5 items. I'll just give an example. Maybe 3, maybe 4, maybe 2. So these are 6 items. 1, 2, 3, 4, 5, 6. Now, this is the list should buy. But then, if we select 3 items from these lists, we should, for example, if we select 3, 4, and 2, we should be able to form 2 extra values that are unique. This becomes our D. So this is the rule. We should be able to form extra values that are unique. We can have maybe 3 and 2. So this is the combination they want us to have. The rule says if you can't form this, then we print sad. Or we can sum up the cost and return the total amount that she needs to spend. For any grouping of n equals to 3 of L accessories, there must be at least D equals to 2. We must have 2 distinct types of accessories. Victoria can satisfy her shopping rule and spend the maximum amount of money by purchasing the following set of accessories. Now, when you look at these accessories, you'll find that we have the most expensive accessories in this set. That's 5, 5, 4, maybe 4, 3, 3. So we first try to purchase the most priced items before we go to the least priced items, because we want to get the maximum amount of money she can use. Now, remember in our rule we say product number 3 costs $3. Product number 4 will cost us $4. So this actually corresponds to money. So the third product will cost us $3. But if we get the sum, we get the total amount of money she can spend probably in dollars. So we print 24 on a new line. Now, shopping trip 2. When we look at shopping trip 2, we know that Victoria wants to buy L equals to 2 accessories. So Victoria wants to buy 2 accessories, but the stores have 1 type of accessories. So this brings up a lot of new problems. We want to buy 2 items that are unique so that we can have a set of n which can give us unique elements, but the stores still sell 1 type of accessory. So for any grouping of n equals to 2 of her L accessories, there must be at least 2 distinct types of accessories. Because the store only carries 1 type of accessory, Victoria cannot make a purchase satisfying the constraint that there be at least 2 distinct types of accessories. Because Victoria will not purchase anything, we print that she is sad on a new line, which is what we have here. This was scenario number 2. Now, how do we go about this solution? Now, we first want to look at scenarios where she fails to buy anything, where we have to print sad. When we look at this scenario, remember, if we are to have n with maybe, let me give you an example. Let's say we have L being equal to 7, and we have maybe A being equal to maybe 6, then we have N being equal maybe to 3, and D being equal to 2. Now, in this being equal to 2, in this scenario, we can pick the 3 items from D. We can pick 2 items from N, and we form D, which will give us 2 distinct items. But then, what if we have a scenario where we have D being equal to 4? This means the rule is broken. So the first thing we have to ensure is D must always be less than N. If D is greater than N, we have issues, then we should return sad immediately. So this is what we shall first take care of. So if N is less than D, we shall print return sad. Now, this is the first scenario. Now, the second scenario is, let's say we have L and we also have N. Then we have scenarios where N is greater than our L. This gives us new issues, because if L is equal to 6, but then we must have a subset of, for example, L is equal to 5, but then we must have a subset of N, but N this time around is equal to 6. You find that we can't pick 6 items from L. So this gives us totally new issues. So we also need to take care of this. We have to make sure someone cannot pick because if this N is a subset, that means L must be bigger than N for us to be able to create a subset of N. So we also have to look at that. And so we say, if N is greater than L, we also need to return SAT. Now, the other scenario is that we need to find the maximum amount of accessories, the maximum accessories we need for us to be able to make a purchase. Now, how are we going to do this? Now, I'll first declare, let's say, let's have our const. Minimum. We need to have the minimum accessories needed for us to be able to follow the rules. Let's say let's say A is 5. A is equal to maybe 3. And L is going to give us is 6. Remember, A has items ranging from 1, 2, 3. Sorry, this is the values. These are the values. Then we have L. L becomes maybe 3, 2, 2, and maybe 1, 1, assuming this is what we have. Now, if we try to pick, maybe for N being equal to 3, if we try to pick 3 items here, we shall have something like 3, 3, and 2. Now, assuming D is 2, like we were given in the scenario, you find that we cannot form distinct items. So this is what we'll have, which makes the rule broken. We can't have this, but remember, in this scenario the rule is broken, so we have to return SAD. So this is what we need to take care of. Now, how do we find that? Now we need to have a value. We are going to first get the number of times N can go into L. Let me demonstrate for you. Let's say L is equal to 3, okay, is equal to 6, and N is equal to 3, and we have this kind of scenario from 1 probably to 6. We have values from 1 to 6 that have been selected, actually to 5, but we have a repeated 5, making a total of 6 values here. 6. Now, if we want to select 3 items from this, we shall have 3 items. This is one of the N. Then we shall also have another one, which also has 3 items, which is also N. So this gives us the number of times N can go into L. So this is more like L being equal to A. Sorry. this is more like L out of N. But then we don't want to have decimal points. So this gives us this number. Now remember, for every subset of N we create, we need to have D distinct values. Let's assume D is equal to 2. So for us to have at least distinct value this side and this side, we need to have a minimum number of items that we need to have to be able to achieve this. So we shall do this by getting this value and multiplying it by D. This ensures that the answer we get, if the answer we get gives us the minimum number of items we need for us to be able to get distinct values. So this is done with, so we shall have math cell, because we don't want to have that in cases where, for example, L is 7 and N is equal to 3, we don't want to have the decimals, then times 3, so sorry, times D. This gives us the minimum number of items we need for us to be able to actually the minimum number of types of items that we need for us to be able to achieve the rule. So we shall check whether this number is greater than A. If this number is greater than A, which are the available types, we shall have to return sad, because if this number is, if the minimum accessories required for us to achieve this rule are greater than the accessories that we in the stores that we have, that means we can't achieve this rule however much we select items, you know. We try to select items for L. Okay. So now these are the 3 scenarios we had, but I want to condense this to have something simple. So I'll copy this. Oh, sorry. I'll just have an value if N is greater than L. We return sad. We don't want to have a lot of code. We want to minimize this. So these are the 2 scenarios that we had to test for us to return sad. Whenever we have numbers that are inconsistent for us to achieve the rule, we shall have to return sad. So these are the 2 scenarios that we needed to consider. Now let's now study that. Let's assume all these criteria fulfilled. Let's now start calculating the maximum spending. Let's first declare a variable for maximum spending. Okay. Let's also have the type, because remember this type starts with a bigger number. For example, A can be 6. The available types. We shall assign A to the types, and we shall have a while loop. Now, the reason as to why we want to have a while loop is because we want to keep on detecting the purchased batch from L, and we need to keep on checking. Whenever we iterate, we need to keep on checking whether L is equal to 0, because this has to keep on decreasing till we hit a 0 for us to terminate this loop. Now it's called while loop. So we have if L, while L is greater than 0. Okay, so we want to keep on buying a batch. We want to keep on buying a specific number of items every time we iterate. Now, how do we achieve this? Let's get the batch that we shall buy, the first batch. remember we have to start with we need to start with the most highly priced product. So let's have math. Let mean. Now I'll explain to you why we have this statement. Let's say we have our L being equal to 7, but we want to keep on buying D products so that we can have these different items, adding them to our cart. Now, for this scenario, we have L being equal to 6, but then there are instances where L will be equal to 7. Now, remember, we are going to keep on subtracting values. Okay, whenever we buy something, for example, if we buy 2 products, we need to subtract those products from L so that we know, we are left with a balance of maybe 4. If L was initially 6 and we find that D is 2, this function will return the minimum number of these 2. Now, initially it will return 2 because L is equal to 6, which is D. Now, let me finish up and explain the logic. Okay, now the maximum spending will be equal to the batch that we've got times the type times the batch. But we keep on adding this value to the maximum spending. If initially the maximum spending was 0, we shall add this. Then on the next iteration, we shall just keep on adding these values. Now, when we've added something when we've bought something, L must decrease by the number of items we've bought. So L minus the batch. Then the type. Remember, if we buy the first most expensive items, we have to keep on decreasing the type so that we keep on buying more items that are different from the ones that we have initially, that we bought initially. So we'll keep on subtracting a 1. Here, we shall return the maximum spending. Okay, now let me explain to you the logic behind this while loop. Initially, we shall first try to determine between L and D. Remember, we want to keep on buying D items as we put them in our basket. That makes sure that we have distinct items. Now, since we are subtracting the type by 1, initially if the type we are given, for example, A being equal to 6 or 5, after buying the first 2 items, if D is equal to 2, we shall subtract type by 1 and we shall have a 4. Now, when we iterate again, we find that L now is 4 and it's greater than 0. We shall continue in the loop. We shall say if between 4 and 2, which one is bigger, we shall return the 2. We shall have this expression. We shall subtract the L. So this will continue till L evaluates to 0. But the reason as to why we have that math.main is imagine a scenario where we have L being equal to 7. So we iterate 3 times and we find that at last L becomes 1. On the 4th iteration, L becomes 1. Now, if L becomes 1, between L and D, we have to be able to determine which one is bigger. If D is bigger than L, that means we have to buy that specific type. For example, L becomes 1, we shall have to buy 1 item of that specific type. If L becomes less than the batch, so less than the D, we shall have to buy L. So this is the reasoning behind this entire loop. Yeah, so if we try to run our code, okay, something. So if we try to run the code, okay, now we get this error. It's because we wrote math.seal wrongly. So let's try to correct that. It's incorrect. It's math.seal. Okay, so let's run the code again. Okay, so yeah, this is the solution to this hackathon challenge. Yeah, thank